Right, so what we are going to talk about today are a little something called ionic compounds. And so you've already been talking about ionic compounds. A few things that you need to know about ionic compounds, right, is I'm going to say this right now, is you may find videos on the internet, you may find a textbook, you may find a prior teacher who has told you this, and it is not true. Ionic compounds do not involve the transfer of electrons. They do not involve that transfer. I have been waging a personal campaign to try and get rid of that. A transfer of electrons is what's known as a redox reaction, and that is a completely different situation. Ionic compounds are formed when you have a positive ion next to a negative ion. They are formed when a group of positive ions is attracted to a group of negative ions. And that attraction, remember, is a Coulombic attraction, right? You've heard that term, Coulombic attraction. And it's very, very similar to the attraction a positive proton feels to a negative electron, right? That's where we talked about this before, with a Coulombic attraction between these subatomic particles, all right? So it is not a transfer of electrons, it's an attraction between those two. And that attraction, as something we're going to talk about later, is what is the ionic bond. It is what glues these things together. Some of the properties of ionic compounds that they have, and we've already kind of discussed this, we've already seen this in lab a little bit here. Properties of ionic compounds are they have high melting points. If you take an ionic compound, like sodium chloride, for example, table salt, and you put it on the stove and you heat it up, it will melt at a very high temperature. Whereas if you take a covalent compound, the compounds we're going to talk about next week, which is like sugar, and you put that on the stove, heat it up, it'll melt fairly quickly. Please don't try this at home. Most of the ionic compounds, they tend to dissolve. You saw this in one of the labs where you could take that and you could dissolve it in water and it would change another property of the water. But another weird thing about them is if you melt them, if you get an ionic compound melted, when it is melted, it conducts electricity. And that's because these ions, right, can transfer electrons all the way down through them. So it kind of behaves like a metal in that sense, that it then becomes conductive of electricity. They also conduct electricity when you dissolve them in water. And it's an interesting fact that pure water does not conduct electricity. Pure water does not conduct electricity. If you take pure water, you try and pass electricity through it, it won't go through. But if you dissolve an ionic compound in there, the more you dissolve, the more conductive that water gets. So your tap water, for example, is mostly conductive of electricity, not because it's water, not because it's wet, but because it has some other stuff in it, some other ions in it. More about that in a later unit.